Hey everyone, and welcome to The Explainer. Today we're looking way past the theoretical textbooks to reveal the hidden physics driving our everyday lives. Because physics isn't just some abstract science, it's literally the foundation of every single tool we rely on, from the minute we wake up to the moment we go to sleep. So let's dive right in.
Here's our roadmap for today. We're going to start with the physics all around us, move into mastering simple machines, and then see how we build compound machines. From there, we'll explore the magic of hydraulics and wrap the whole thing up with tech, health, and daily life.
All right, Section 1. The physics all around us, hidden in plain sight.
So have you ever actually stopped to wonder exactly how physics shapes the items we use every single day? Whether you're dealing with force and motion on your morning bike commute or just feeling the thermodynamics of sunlight hitting your skin, you are constantly interacting with complex physical laws in real time. It's kind of like we have this hidden engineering logic built right into our minds. As humans, our brains are beautifully wired to process these invisible rules of physics. We just instinctively anticipate how objects are going to interact. We manipulate our environment to solve physical problems without even thinking about the complex math behind it. It's pretty amazing.
And when we take that instinctive understanding and apply it formally, well, that's where we get ergonomics. Basically, the science of designing tools efficiently and safely for human well-being. By studying exactly how forces act on the human body, we can engineer tools that maximize comfort and actively prevent daily fatigue and injury.
Just think about the chair you're sitting in right now. If it's an ergonomically sound chair, it's a precisely engineered physical support system. It uses lumbar depth adjustments to support your spine, adjustable armrests to offset shoulder torque, and a tilted seat to keep your pelvis in a neutral position against the constant downward pull of gravity. It's literally physics cradling you while you work.
Moving right along to Section 2, Mastering Simple Machines, the Building Blocks of Tools.
Now, it really helps to map these abstract machine categories directly to tactile items we handle daily. A wedge, that's simply the knife you use to chop vegetables. A pulley is the mechanism hoisting up a flag, and a wheel and axle is the exact reason a stroller is so effortless to push. These devices fundamentally alter how our effort is applied.
The true efficiency here comes down to mechanical advantage. With a kitchen knife, notice how the specific length of the blade relative to its thickness impacts the wedge. The physics of that very specific angle takes your downward push and amplifies it outward, making slicing through material incredibly efficient.
It's a similar story when you push a stroller. You're applying force to the outer wheel. And because of the size difference between that wheel and the central shaft, the axle, that rotational motion provides a massive mechanical advantage. It lets you move a really heavy load forward with very little physical input on your end.
Okay, on to Section 3. Building compound machines, scaling up complexity. The distinction here is straightforward, but honestly, it's profound. Simple machines change the direction or magnitude of force with no distinct internal parts. Compound machines, on the other hand, take those wedges, levers, and wheels and combine them. By transferring motion across multiple parts, they can accomplish heavy-duty tasks that a single mechanism never could on its own.
From a standard pencil sharpener sitting on a desk all the way up to a massive bulldozer, we are constantly surrounded by layered physics. A lawnmower uses wheels and axles to move while utilizing wedge-shaped blades to cut. A bulldozer combines levers to lift with a massive wedge to move earth. It's just simple physics layered together to create immense power.
That takes us to Section 4, the magic of hydraulics, fluid power at work.
This brings us to a personal favorite, Pascal's principle. It states that a change in pressure applied to an enclosed, incompressible fluid is transmitted undiminished to every portion of that fluid. So, because pressure equals force divided by area, applying a small force to a tiny area of fluid basically multiplies into a massive output force on the larger side. It feels like total magic, but nope, it's just pure physics.
And we rely on this fluid power all the time. When a garbage truck effortlessly lifts those massive bins, or a barber raises their chair with just a few light foot pumps, that's hydraulics. Even pressing your car's brake pedal to stop a 2-ton vehicle relies on fluid pressure, multiplying your force. It is literally the invisible muscle of our modern infrastructure.
Finally, Section 5, tech, health, and daily life, invisible forces.
Expanding our scope to invisible energies for a second, thermodynamics, which is the study of heat and energy, is the whole reason your refrigerator preserves your food.
Electromagnetism allows MRI machines and X-rays to peer inside the human body without any surgery. And optics, the study of light, that's what corrects our vision and lets us explore the cosmos.
This incredible web of smart devices, laptops, and global communication networks that we use every day, it is the ultimate culmination of these exact principles. Without a deep, applied understanding of electricity, magnetism, and wave properties, none of this connectivity would exist at all. Physics is quite literally the foundation for our entire globalized world.
So, I want to leave you with one final thought to chew on today. What is the true role of physics in solving real-life problems in our society? When this explainer is over, I challenge you to just look around your room. Try to identify the simple machines, the thermodynamics, the invisible forces at play. Once you really start looking, you'll realize physics isn't just some subject you took in school, it's the very fabric of the world you navigate every single day. Thanks so much for joining me on The Explainer. Keep observing and keep questioning.